Hello, my name is Michalis Pachilakis. I'm a PhD student at the University of Crete, and today I'm going to present you our work in the real-time bidding advertising ecosystem on how to measure its price dynamics in a privacy-preserving way. This work was executed based on funding from EU Horizon 2020 projects, CyberSec for Europe, Concordia, Accordion, PIMCity, and the Protas project. I will start my presentation by providing information necessary to understand what the real-time bidding advertising ecosystem is and how it works. I will then explain the motivation behind this work and describe our system design and architecture. I will present the data collected before I jump in a detailed analysis of our results. Finally, I will discuss our system limitation before conclude this presentation. Each day, billions of users visit websites to chat with friends, read the news, or even watch the weather. The gas that fuels the internet and allows publishers to provide their services for free is online advertising. Typically, publishers allocate placeholders in their websites or as they record ad slots, where digital advertisements are being displayed to the users. Currently, the most popular form of online advertising is called real-time bidding, where real-time auctions take place normally in less than 100 milliseconds. Real-time bidding promises tailored advertisements to the interests of each individual user, which optimize the cost, efficiency, and speed for both the advertiser and the publisher. The whole real-time bidding ecosystem is a complex construct which is compromised by several different entities. Here, we see in more detail the process of rendering an ad to the user, display, and all the entities that collaborate to achieve that. Upon visiting a publisher website, a real-time auction for each available ad slot gets triggered and a request is sent to the supply-side platform or SSP. The SSP is an agency platform that allows the publisher to manage their ad inventory. The SSP then notifies the ad exchange, which is where the actual auction takes place. We can think of it as a stock exchange which enables advertisers and publishers to buy and sell advertising ad space through the real-time bidding auctions. The ad exchange will then request bids from all the demand-side platforms it collaborates in order to determine the winner. The DSP is an agency platform that can help advertisers buy the best matched ad slots. Once the winner is determined by the ad exchange, it will be sent to the user's display, and once successfully rendered, a notification message will be sent to the DSP that won the auction. The notification message or notification URL is piggybacked in an ad response passed through the user's browser and acts as a callback to the DSP. This ensures the DSP that the winning impression was indeed delivered and rendered correctly. The notification URL contains the winning DSP domain, the price charged, the impression ID, and other logistics. We have to note that major ad companies tend to encrypt important information in the notification URL, like the price charge, to ensure the integrity of the reported values and avoid the prying eyes of the competitors. Here we see a real-world example of a real-time bidding price notification URL with winning DSP the pocket math and charge price 0.95 CPM. The whole process of a real-time bidding auction is completely opaque to the users. Typically, they learn little, if any, regarding the prices that advertisers are willing to pay to render their ads in their screens. Motivated by the lack of transparency in the real-time bidding ecosystem, we strive to implement a first-of-its-kind transparency software for programmatic advertising of the real-time bidding. Its goals are to help users better understand the value of their digital footprint in order to make more informed choices about how they wish to participate in the emerging data economy. It also aims to help data protector authorities, regulators, and watchdog groups to detect signs of bias and discrimination against particular demographic groups. Finally, it aims to shed light on the factors that affect the pricing dynamics of the ads displayed to the users. We named our software YourAdvalue, and it's a JavaScript browser plugin that monitors and reports in real time how much money the advertising ecosystem pays to capture the attention of the user by rendering ads on their display. YourAdvalue was designed and implemented by applying the following design principles. First, it should be able to operate in real time and inform the users of updates as soon as new RTB ads are being detected. Also, the RTB protocol should remain untapped so that the detection mechanism does not alter the RTB protocol or add extra latency to operate. It should be simple to understand, so even non-technical users can easily read and adjust the metric reported. The plugin should be fault tolerant, so it can continue to function even after it encounters unexpected behavior. The RTB detection should be generalized, meaning it should be able to operate and detect ads across any website. And finally, it should be able to detect both clear text and encrypted prices. YourAdvalue has two main components: the end-user client or web extension, which executes a web request inspector that analyzes the incoming and outgoing network traffic of a website and detects in real time the RDB-related notification URLs. And the backend, or the web server, which receives the anonymous metadata for further analysis. Here we see a high-level overview of YourAdvalue. First, the user needs to visit the website, and as soon as it does that, all requests leaving the browser are being inspected. We leverage the notification URL mechanism to detect only requests sent to known DSPs. We also utilize a list of known DSPs and their corresponding price keywords for faster detect and possible match. If the user consents to data sharing, anonymized data are being sent to a remote server for further analysis. We ensure that the data does not contain any personal identifiable information and cannot reconstruct the user browsing history or behavior in any way. Here we see YourAdvalue's UI. The UI is simple and intuitive, and it was designed with the help of a UI/UX expert. First, it allows the user to specify their gender and age range if they want. It displays to the user several metrics such as the total number of ads and the total cost computed for the user for the time the plugin was installed, and it also presents the same metrics for the current session. Finally, there are simple buttons which allow the user to enable or disable the data sharing functionality and switch on and off the plugin. The design of the extension is light, and it was tested on hundreds of websites to ensure it doesn't hinder the normal loading of each site. As we already explained, YourAdvalue leverages the notification URL to detect ads and extract prices. Here we see in detail the path the request follows to determine if it corresponds to an ad. First, it checks if the outgoing request is a notification URL. It compares its destination to a set of known DSPs. If it doesn't match any, it is allowed to pass. Otherwise, we consider it a potential notification URL and extract metadata related to it. Then we check if there is a possible price keyword in the metadata, and if it relates to a notification URL advertiser. Since each advertiser utilizes some specific keywords to indicate the price in the notification URL, we use a list of advertiser keywords combinations. If it doesn't match any of these combinations, we consider it a false positive and let it pass. Otherwise, we extract the price value. If the price value is numeric, it is normalized to US dollars and added to the user total. Otherwise, the tool utilizes a decision tree to estimate the value and add it to the total. To conduct our study, we advertise YourAdvalue across different social media networks and groups. As we said, we don't store any user identifiers for our users, but since we made our plugin available for download from the Chrome store, we were able to get an intuition about the active users from the information that Google provides to developers. For a period of 11 months, about 200 users installed our plugin, and we received about 12K impressions. We received 4K impressions from males and 6.6K from females. We also received 9.8K impressions for the 25 to 34 age group and 1.2K from the 35 to 44 age group. So let's now dive into the analysis of our data. In the first plot, we see the CDF of the DSPs involved broken down by age. We found that the particular DSPs have preference for specific age. For example, AdNXS.com and AdServer.org deliver more ads to younger users, where in contrast, BlueKai, Criteo, and OpenX target older users. Similarly, the next plot shows the CDF of DSPs involved broken down by gender. Again, we see that particular DSPs have preference for specific gender. AdNXS.com and AdServer.org deliver more ads to female users, where in contrast, Cattle Media and Criteo target more males. In general, DSPs may have a preference for specific genders and age groups. Also, this can be the result of the type of campaigns that were running at the time of the data collection. In order to better understand the evolution of the real-time bidding ecosystem, we compare our data to the data available from past real-time bidding studies. The only other studies on real-time bidding come from Learning in 2013 and from Papadopoulos in 2015. In 2013, there was conducted with automated crawls and a set of 100 users for a period of 1 month where 400 impressions were collected. Since no dataset was released, we used the statistics reported to compare with our findings. From 2015, we use a shared dataset on real-time bidding in mobile. It contains 1 year-long activity on real-time bidding with about 80K impressions from 810 users. The dataset collects similar metadata to ours, so we can directly compare price distribution during those periods. Here we compare the CDFs of real-time bidding clear text prices for the 2 time periods we have detailed data. We find that the median price in 2015 is 0.29 CPM, where in 2019 the median price was 1.42 CPM. We also note that in 2013 the average price per user was 0.43 CPM. We don't collect user IDs, so we cannot analyze the price per user, but we can compare with the total average price of the ads collected. We find it to be 2.44 CPM. In general, we observe a 4.6 time increase in the past 7 years and a 3.6 time increase in 4 years. Next, we compare the price we found for each day of the week. In 2015, we observe a relatively stable distribution with a median value at around 0.3 CPM. In contrast, in 2019, we find that during weekends and Monday, the ad prices tend to be higher, with a median varying from 0.83 CPM to 2.5 CPM. We then study ad prices with respect to the time an ad impression was displayed. The result from 2013 confirmed our findings. Prices are higher in the morning hours. We also observed higher prices when comparing to findings from 2015. Next, we investigate the distribution of ad prices across different tier categories. We use general statistics from 2013 and the distribution data from 2015 to compare the ad prices per year category in 2019. We observed that the average ad price paid per year category is not the same across categories, and that in 2019, RTP prices are higher on average for all reported years on 2013 and 2015. However, the most popular real categories, news and entertainment, are not the most expensive with respect to the ad slots. Next, we focus on some demographics on our real user base from 2019. Here we see how much advertisers are willing to pay to reach users of different gender. We find that advertisers are willing to pay more to target women than men. For female users, the median price was 2.5 times more compared to men. This can be explained by the earlier analysis that showed that females are more targeted by specific DSPs, and it's also confirmed by past reports. Here, we see the price paid by advertisers based on the self-defined age of the users. We observe that advertisers are willing to spend more on younger users compared to older ones. Also, for the younger group, advertisers are willing to go as high as 9.4 CPM, whereas for the older, the maximum reaches 5.21. Since younger users are more receptive to ads, they could be a more profitable target group. In this plot, we present the prices for the top 7 countries found based on volume. The top 3 countries are US, Switzerland, and Spain, with median prices 2.49, 1.47, and 1 CPM respectively. We note that in 2015, the median price for Spain was 0.29 CPM, and for United States in 2013, 0.69 CPM, indicating 2.4 times increase in 4 years and 3 to 4 times increase in 7 years. Finally, in this plot, we present a breakdown of the major DSPs involved in real-time bidding for the detected ad prices. When compared to the DSPs found in 2015, there are differences which are to be expected, given that in 2015 was on mobile, where on 2019 on desktop. The top DSPs are AdXNS, AdServer, and Criteo, in which the median prices have increased from 3 to 17 times in a period of 4 years. In 2013, the most popular DSPs were Invite Media, Term.com, and Mathtag, and in 2019, we were able to detect only Mathtag with the median price has increased by 10 times. Of course, our work comes with some limitations. First, the users are free to use ad blocking or anti-tracking products. Even that the users of such product doesn't affect your ad value, it will eliminate or greatly reduce the ads delivered to the users, meaning that it will eliminate data reporting. Second, the number of users was not stable. Users were allowed to install the plugin, disable, or even completely uninstall it. Third, the reporting users are assumed to be real. Since YourAdvalue is a plugin related to specific interest and was advertised in different privacy-aware communities, we believe our audience has no intention to be malicious. Finally, we have no control over the user's browsing behavior, which introduces a limitation on comparing users of opposite site demographics. So to conclude, we designed and implemented YourAdvalue. RTB prices have increased 4.6 times in 7 years. Weekends and Mondays tend to have higher ad prices than weekdays, and also ad prices are higher during the morning hours. Advertisers pay 2.4 times more to target women compared to men, and younger users cost 2.5 times more compared to older groups. So thank you very much. If you have any questions, I'll be happy to answer them.